All right. In a z proportion, not a z proportion, a t-test, we do not know sigma. So if you read the notes, we don't know sigma. So our standard error and confidence interval changes to using t instead of z. Instead of using sigma, we use the s of x. That comes from your sample. Our one sample t statistic formula looks just like the z formula, except instead of sigma, we use s. That's about it. But then we also have to introduce something called degrees of freedom, df, which is your sample size minus 1. Looking at the curves, the larger your sample size, the more the curve looks like a normal curve. That's why we use the degrees of freedom. The larger your sample, the better. The better. Now, here we go, jumping right to the confidence interval formula. I already showed it to you. X bar plus or minus t star s over the square root of n with n minus 1 degrees of freedom. I will show you how to use your table. You already have your charts. You should get out your t table anytime now. It's in your formulas, your charts. You're finally going to look at it. I got one on the internet. I can show it to you.
There you go.
Now it stopped.
No, it's going.
Oh, okay. It must have stopped when I went and closed it. I close it. All right, back on. All right, guys, only thing you need to do is get out your charts. Now, hypothesis testing. We've been doing that forever. Hardly any of it changes. Maybe you only want to write down the notes that it changed. We always describe our parameter of interest mu. Have we done that before? Mu is the true average of puppies' weight when they're born. 2, describe the test you are using. Right now, what kind of test are we using? A one sample t-test. In your given, this is your given, guys. You need to have n, your average of the sample, and the standard deviation of the sample. Where do you think you get those if they don't tell you what they are?
Calculator.
Yes, you put the data in yourself, and you use your calculator. Also, one of the other things you need to write down is your alpha. He mentions it later, but I like to put my alpha in my given. Conditions. That's going to be different. So when you get to conditions, pay attention to what's different. We still have our null hypotheses. Does this look familiar?
Yeah.
H naught. Mu equals to mu naught. Mu is the population parameter. Mu naught is what I think is true. And then you also have the alternatives, just like you had before. HA, you have the left, the right, and you have the neither. I don't know if you mentioned neither. Let's see. Oh, two-sided test. That's the not equals. We have the less than, we have the greater than, we have the not equals. Then we got to find our test statistic using this formula. T equals x bar minus mu naught divided by s divided by square root of n. And when we use this formula, you will realize we're going to teach you how to use the degrees of freedom. He gives you some directions right here. I don't know if this is going to make any sense to you. To find your p-value, we use our z-table. We choose the row for your degree of freedom, which will be n minus 1. You look across the row until you find the t-value that you have just computed. You probably will not find it exactly, so you find the one that's closest to it. Okay? And then you read up to the top row and calculate the upper tail probability, the area of the tail. Describe your alpha somewhere. I like to put it in the given. Use 0.05 unless they say different. You found your p-value with your table. If it's less than alpha, what do? Reject your null hypothesis. What if it's greater than alpha? Which inside your heart you're saying, oh, if I fail to reject the null, I bet you the alternative might be true. Right? And then, like always, you make your conclusion in English. Okay? So, let's see here. Conditions. Okay. First condition. Is that a surprise? SRS?
What? No.
Is that a surprise? No.
It's not.
And if he doesn't give it, what do? We assume it.
Is that the next?
Yeah, no, it's the same thing. We always assume an SRS. If it's not clearly stated in the problem, it should be mentioned as assumed. Because you want them to know that you know it should be random. Now, look at the conditions about your sample size. If your sample size is less than 15, he says you can use the T procedures if the data in the sample appears normal. Well, how do you know if the data appears normal? What kind of graph? What kind of graphs do you put one list in to see if it's normal? So sad, guys. Histograms.
Oh, histogram.
Or dot plots, but you can't put it in the calculator. No, we've done it before. We had to justify conditions of some data before the z-test.
Yeah.
We weren't allowed to use data that had outliers. How would I check outliers? A box plot.
Wow.
The modified box plot will show you if a data is outside. So let's see. If your data is less than 15, use it if the sample appears normal. If the data is clearly non-normal or there are outliers, do not use the T procedures. It doesn't have to be perfectly normal. If you could say it's almost normal, except for a few bad pieces of data, then go ahead and use it. But you might want to put a picture down and say, it's got some skewness, but I'm still going to run the T procedures. It might be skewed a bit, but I don't think it's skewed enough to hurt it. That's just your call. You make that decision. If your sample size, this is why we like a bigger sample. If your sample size, the next one says, is less than 30, that means it's bigger than 15. Look what it says. Less than 30, bigger than 15. It is safe to use the T procedures unless there is a very strong, slide over. Hate when it keeps bouncing back. Unless there's a very strong skew. So he didn't even ask you for outliers. He just said, if it's bigger than 15 but less than 30, if there's some skewness, we'll run with it. But if your sample size is 15, some skewness could be actually bad. So I hope you don't ever get sample sizes less than 15. Because then you really got to justify what gives you the right to run this test. If it's got skewness, you need to write a comment that the skewness may be so bad that maybe the results aren't accurate.
That's correct.
Yes?
If one of these rules aren't applied, then we just don't do the test at all.
Okay, you have the right in the real world not to do the test. But for me and for the AP test, you're still going to do the test, but you're going to document the problems. You're going to let them know, hey, you didn't mention SRS. I'll assume it. Hey, my sample size is only 13, and it looks somewhat skewed. I am going to, how can I put it nicely? I'm going to run the test, but I'm going to question the results. Now, if the sample size is bigger than 15 and less than 30, skewness don't hurt it as bad. We don't even ask for an outlier. But if there's an outlier in less than 15, for sure, you're not supposed to run it. Outliers are bad. But if that's all you have, and they're telling you to do the problem, I would do it, but let them know that I think my results is garbage. I'm just wasting my time doing this for you, Mr. College Board. But the data's flawed, okay? Now, the good news is, if your data's bigger or equal to 30, it is always safe to use the t, even if you see outliers and strong skewness. We've talked about that before. Remember that a big sample size fixes everything? Yeah. It doesn't even matter if you do a histogram and you got an outlier and it's skewed, but your sample size is 35. So what? Run with it. Okay, does that make sense? So now you got to pay attention to how big is my sample. All right? Now he says, when you do a hypothesis test or confidence interval using t, you should note whether the conditions are met. It's what we're being mentioned right here. He said, do I go? Joel says, do we continue? If they are not, here it is, Joel, you should proceed with the test anyways. And then make mention of your concerns about the accuracy of the test. Yes. Isn't somebody already gone? No? Go ahead. So an example, if your SRS is assumed, okay, so they didn't tell you, so you're assuming it, and your N is 20, 20 is bigger than 15, but it's not bigger than 30, the data appears normal. What would you do with that one? Would you run it? Yes. What if it's SRS and is only 9 and there's an outlier present? Would you run it?
Yeah.
No.
Just mention it.
We're talking about for reality.
Oh, reality.
No. Now, you will run it for your test and you will run it for your class, but you will also say, the result of this hypothesis is open to question. You want them to know that you only did it because they told you to do it, but you wouldn't have done it if you were being paid by a company.
Okay.
Okay? A confidence interval or a significant test is often called robust if the confidence interval or p-value does not change if very much when the assumptions are violated. The t-test is robust. You can violate a little bit and your data still, the results are okay because the test is very robust. Robust means it's very powerful. It's forgiving. It will still give you the results you want, but question it.
Oh.
You know, when we do confidence intervals, you must mention the conditions as well. Why?
Why?
Because it is a form of a hypothesis test. I've told you that.
Oh, yeah.
How many times did I say, wow, that confidence interval actually gave us the same conclusion as our hypothesis test, remember?
Yeah.
Yep. Now, we could go on to comparing two means and talk about the new formulas and stuff, or we can move on and do a practice problem.
Practice problem.
Or can we do
That was
a
a
problem and then go back?
I don't know. Well, it took 20 minutes to go through it. We'll
That's
see.
not bad.
Yeah.
Oh, I had a quiz today, too.
What? We took a quiz last time.
So we gotta do those
No, but your quiz last time was on what?
Homework. Homework quiz. Sir, I didn't take that.
But it was-
taking it for homework. Sir,
What homework, though?
the one you took.
Oh, you took that one already.
Yes. Wait, I didn't take
Oh,
it.
yes.
Oh, sorry,
Mr.
take
Sir.
it.
Mr. Sir.
And you like your score on that, right?
No, can we retake it?
You said you were going to let us use the
Can we
homework.
take it again?
I'll think about it.
Oh, yeah.
Hold on. All right, move on. Okay, let's go to a problem.
You have to give us back our homework, right?
Let's go. Yeah. Oh, if you take it again, I'm not going to give you back the
I
homework.
haven't taken it.
I haven't taken that.
Why?
We were both
You
at
said you were going to
Rosa.
give us
Yeah,
the
we're
homework.
Yeah, we're all
Use
at
the
Rosa.
homework. You said-
Oh, yeah, how's that, people?
Yeah, hold on.
All right. We'll see. Pay attention, though. You guys get off task very easily.
Sorry.
Let's do a problem. There is a...
Is that on here, sir? The one that you sent?
No. Well, yes. It's when you send. All right, there's a blank grid because we could have actually done this. There's instructions in this textbook called Practice of Statistics, and I have the instructions for this. How to fold paper to make a fixed wing airplane, how to fold for a jet plane, and there's a third plane. And back in the day when I had classes that all behaved and didn't play around all the time, we weren't behind it all. We could go to the hallway and you and your partner could actually throw your paper airplane 3 times and take the average distance thrown. That average distance, then you throw again 3 times. What you would do is actually you're going to be throwing probably like 60 times because I want a sample size of like 20. So you could just throw 20 times and get 20 measurements, or 30 is even better. Okay, 30 is even better. And what you do is measure it. So what would happen is the guy who put this together, he'll tell you right here, that this is data from one of his classes. We're going to use that today. If we can get our act together the next week or so, we'll see what we can do here. Over the years, he's done this experiment. He found that students were able to throw the fixed wing plane an average of 7 feet. On average of 7 feet. He found on average that was what they were throwing it. Okay? He wants to know, is there evidence that this statistics class, this one right here, can throw it farther than 7 feet? Explain why or why not you can make the claim. And then he continues, you're going to be talking about the hypothesis test. You're going to do a hypothesis test. Assuming that the statistics class is a random sample of students, which is very debatable whether you guys can be considered as an SRS. But I think what we do is we statistics teachers say, how'd you get this class? The computer randomly picked all the stats kids who could fit this class. Then it fit how many of those stats kids have to change the schedule because of another class, so they get randomly pulled out. So by the time we get done, you are basically randomized in some form. They didn't just go down the alphabet and say, A through C is in period 1, D through F is in period 2. They didn't do that. They didn't sort you by student number, which that would be okay. Because student number is, it's weird when you find people who have the same last name as you, they don't even have a student number like you at all. Your student number is based on different characteristics. Anyway, is there evidence that the students in this school are better at flying fixed planes than the previous class? Remember his previous classes, he always thinks about 7 feet is the average. Show all your work. Also, find and interpret the 95% confidence interval. So the reason it takes so long to do this, I got to show you how to use that T-table, because I'm not using a calculator. This is number 1 right here. We're going to do the first one here. We're going to use this data. So the first thing I guess we need to do, we need to put that fixed data, the top row, in our calculators. So let me zoom in and put half of it on the screen. Get that in your calculator. List 1. Do a good job.
Wait, I can't see all of them.
No, I'm going to move over in a minute.
Oh, wait.
Get those first ones in.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. That's almost half of them. I think there's 19.
Wait, all in one row, right?
The first row. Just the first row.
Starting with number 1? Yeah.
Yes, the first row is fixed. The second row are jets.
Okay, wait, so we just do fixed right now? Or
We're just doing fixed.
All right. Wait, sir. Okay, no, you're good.
It's obvious the jets go farther.
Whoa.
Why do I got 6 people over here and I got 0 people keying it in? You got those in already?
That was quick. Hair looks nice.
You're just now getting your calculator out, Vanessa?
Sir, do you have batteries? Yeah.
I don't.
I'll bring this one.
Can I scroll over?
Yes.
Okay, I'm going to go over past the 7.4 here. I think you already have that 8.6, right?
Yeah.
Do you already have the 8.9? Okay, let me just get off the 8.6 then. We don't need that. There. The reason they're putting the data in, not because we're doing the test with the calculator today, but how else are we going to get the X bar? How else are we going to get the standard deviation of that sample?
Sir, wait. Can you move back a bit?
I thought everybody got that
Okay,
8.6.
never mind. Yeah, I was making sure. That's good. 8.9.
So is that 11 the last number?
It's actually 11.7.
That's the last digit?
Yeah.
No, you lied.
14.
There's one more.
And then there's a 14.3. Well, hold on. Let me just wait till they get caught up or they're going to get
I'm
lost.
caught up. I'm caught up.
You all caught up?
Yeah.
14.3.
9.1.
Everybody got the 9.1?
Yeah.
I didn't hear anybody say no.
Yeah.
Keep going, sir. Keep going. There you go. That's good.
It's just 20 numbers right
No, there's 19.
18.
19, yeah.
18.
18?
Yeah, I got
18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 19.
I got 19.
I have 18.
No, there's 18. 19. Look, I just counted them.
Wait, what's up for 19?
Check again.
Okay.
I got 8.
So 12.4.
19 numbers.
8.4.
Thank you.
I'll cast it.
Found it? Okay. So, everybody got them in?
Yes, sir.
So,
They're 19.
19. Your blank should say 20. Now, what's the name of the test we're going to do? Because what we're going to do is we're going to see if that class is better than what his other classes have always averaged. What kind of t-test? No. One sample t-test. And the given has to be these things. I need us to know what n is. I need us to know what x bar is. And I need to know what standard deviation is. And then I always put my alpha. Alpha's 0.05, just because. So what was my n?
N is 19.
Ooh.
19.
Yeah.
What is my x bar?
8.4316.
You are the fastest person on that. 8 point.
I got the other one.
8 point what?
4316.
You got the other one, Paloma?
Yes. 3.2578. Okay, no.
That is it. I remember it. Nice.
Wait, I want to see what happened.
Ladies, parameter of interest. Mu. Mu is the true average distance a fixed wing
Disgusting.
paper
Airplane.
airplane
Then the airplane.
true average. It's not really a fixed wing. It's a true average distance that all fixed wing paper airplanes travel. It's the true average of all the paper airplanes. My conditions. There weren't that many. There's SRS. Is it? Did he say it's SRS? Did he randomly select students?
Could you go back to class?
Go back to what? The question?
Yes, it does. Right there.
He said, assume the class is a random sample. So I'm going to write assumed. Now, the next condition has to do with my n. N is equal to 19, right? What must be true about with 19? What did it say? Did you write it down? 19 is bigger than 15, so I don't really care about outliers, but it's not as big as 30, so I still need to look at maybe my skewness. Don't I? What was 19 need to worry about? Strong skewness? Strong skewness is bad, right? So how am I going to find that out?
By graphing.
Okay, so you already have. I'm going to write histogram, and it's in the real world you should draw a picture. Histogram shows nearly normal without two outliers. Without it. It would be normal without it. Two outliers skewed to the right. So I'm letting them know, I'll add that, possibly two skewed.
What's the standard deviation of 3.25?
3.2578. Possibly too skewed for accurate test. I'm going to write it. I don't know what the author said, but I'm going to write it.
Did we see what the author said?
Not right now, because we got a lot more to do. Null and alternative hypotheses. This is the important stuff. H naught. Mu is equal to, no, it's not. What did the teacher say? In the past, he's been confident that his students usually average what? 7 feet. I'm going to write that out. True, average, distance, fixed wing planes is 7 feet. Fixed wing. But he wants to check this other class to see if mu is greater than 7 feet. True distance is greater than 7 feet. I'm not putting all the words again. True average. Now it's time for the Z test, the Z score. No, sorry, T score. This is what's going to take the time. I got to teach you. Got your tables out? If you don't have your tables out, I know what somebody said last class, but sir, at Khan's Academy, we already did this, but we got to use the calculator. And I appreciate that. And guess what? If this was an AP test or one of my unit tests, guess what I'm using? My calculator. Yes. T equals to x bar minus mu naught over S divided by square root of n. X bar, somebody gave that to us, is what?
X bar is, follow more X bar.
Somebody gave it. 8.316. 4316 minus 7 over, and my average was?
19.
No, I mean, sorry, the S, the standard deviation.
3.2578.
Divided by square root of 19. All right, I need, Katya, where's your calculator? Why you're not typing these things in? Give me the numerator. The 8.4316 minus 7. And
Sir, can I give the total?
the final answer?
Yeah.
Okay, after somebody gives me the denominator. Diego, you give me the denominator. I do it in baby steps when I'm not cheating with the full.
Can I just do the whole thing?
No.
Wait, but I already got
I just want to know 8.2578 divided by the square 19.
Let me write the form.
1.8944.
Which one is that? The top?
No, the bottom.
Oh, why'd you do it for him?
Then I'm impatient.
1 point what?
I'm sorry, no, okay.
1.4316.
Oh, no, you're right.
Divided by 1.8944. The final answer, Diego, was?
945.
Say again?
No.
1.45?
No, don't listen to the question.
It's 0.75.
That's exactly what
Oh, I didn't get that last period. 0.75.
0.75.
No, I didn't get
I
that.
got 915.
Oh, haha, I'm wrong.
What?
Oh, I got 915.
915? It can't be. It has to be.
Okay, yeah, makes
Oh, 1.915. Oh, yeah,
Wait,
yeah.
no. I don't.
1.915. Yeah, I think I remember that. Now, how do we use this to get a p-value? Okay,
Wait, sorry, I didn't get that. No kidding, can you hear me? I think.
you got it.
No, I didn't. Wait, the last number is 1.894 what?
8944.
Oh, that's why I put 47. Never mind.
So, okay, I'm going to pause it again and go to the calculator. P-value is less than 0.05, but greater than 0.025. Is that true or false?
That's true.
That tells you a lot.
Yeah, it does.
Because if it's less than 0.05, what do I do?
You reject each not.
So I'm going to reject H naught. Because the p-value is less than alpha, which is 0.05, right?
Yeah.
So conclusion. Rejecting H naught. Rejecting H naught. What do I want to write? Because let's finish this. Because there is. Okay, you want that word? Substantial. Oh my gosh. Statistical and strong. I don't know if it's that strong, guys. Strong evidence that the true mean distance, mean is the average, mean distance,
Is more than 7 feet.
all fixed paper, no, fixed
Words.
fixed wing paper planes is what did you say? More than 7 feet. Look at that. That did take us. Oh, wait a minute. I cheated. I was wondering why. Look at. I said reject H naught. I don't know why I continued writing all this. This could have gone right down here, right?
That's fine.
We got it. So now he wants a 95% confidence interval. Formula. X bar plus or minus T star S of X over square root of N is, plug in my numbers. What was my average again? 8 point what? 8.4316 plus or minus. I need a T star. So let me go back to my table. Remember what I need here. I need the T star for this tail. If it's 95%, what's the area of this tail? If this is 95, what's the area of this tail?
2.5.
Thank you.
My man.
2.5% or 0.025. So I'm going to pause it again. 2.101 is my T star, times that standard deviation, the one that Paloma keeps telling me. What was it again? 578 over the square root of 19. So now pick up your handy dandy calculator. Remember what I told you to do. Do this side first, save it, and then go this number, subtract this number, add this. Do you remember that?
Yeah. Yes.
Okay, should I spin the wheel of death?
No.
That's too much work, sir.
But for you, it's worth it.
Oh.
What did y'all get?
What'd you get?
6.8 and then 10.
I got
Wow, you guys are fast.
Quick,
Because we're
Wait,
smart.
you got 6.8 and 10.00.
Same.
So Brenda, what'd you get for the left? They called you Brenda today. I heard them.
Yeah, Brenda.
I got
Brenda.
I said, oh, look at, they're calling her Brenda now.
Brenda.
She likes it, I thought. She likes it. Who was it calling? It was Joelle, wasn't it?
What'd I do?
You were calling her Brenda.
Never in my life.
And I thought, she likes it. She didn't say nothing. Okay, she's not Brenda. What'd you get for the left?
6.860.
Wow.
4-3?
1.3.
1-3.
Kimberly.
Christian, what'd you get for the right?
I don't know if I did this right. Did you get,
Did it
Chris, did you
right?
get 10.002?
Yeah, actually, yeah, I did.
Is he lying?
Nah, I'm serious.
Oh, it is 10.002?
Yeah, that's what I got.
What was after the 002?
That's
It's
it.
like 19.
It was actually a 19?
Yeah, but it rounds to 2.
Oh, but we do 4 decimals though.
Yeah.
Oh, okay.
So, but here I'm going to round it.
Well,
I am 95% confident that the true mean distance of fixed wing paper planes is between, I love it, 6 feet and
And 11, right?
11. Oh, you got it. You didn't lose that decimal. You got,
We're learning.
oh, I feel so like a proud parent. 6 feet and 11 feet. How was that?
Oh, wait, sir. My only question is, how do we know when we're supposed to use t-test and z-test?
Okay, before I hold on here. We got a lot of smart people in here. Watch this. Watch this.
not me. I already answered too much today.
Yeah, because you're smart.
Finish smart out.
He wants to know, how do we know it's a T and not a Z? All right.
Uh-oh.
If somebody on this side can raise their hand and tell me,
What?
on today's quiz, 10 points.
Wait,
How do you know it's T and not Z? There's the hand.
Because
Go ahead.
You know Sigma?
Oh, perfect. Perfect.
My bad.
Our side, right?
You did one for this.
Yeah, but
wait, can I?
nice job.
All taking notes.
And see, guys, what's wrong with you guys?
Wow. My bad.
All right. That was a confidence interval. Let me just stop this and save this. Yes. Who does?
Me and her.
Well, arm wrestle. Who's going first?
Can I go first?
Arm wrestle, the winner. Okay. I'll hold off on this number 3 thing because we've already done the 1 and the 2.